Cartoon Guide of Chemistry. Now let's go instead and get started on video 3. Finally, we're gonna have explosions and people banging off fireworks, and they're all like, ooh la la, bang, bang, firecrackers, people. Let's go ahead and start talking about solutions. Warning and note, if you're marooned on an island and have a lot of resources and good chemistry knowledge, then this will probably help you survive that island and progress your civilization by 300,000 years ahead of the Stone Age. Anyway, back to the chapters. Now, there are lots of things about chemical reactions. In fact, chemical reactions, well, as most movies actually portray them, is just people mixing together liquids together or gases together, putting a little heat in it, or just mixing together, putting in a fridge, and as instantly as they put it in the fridge or they start heating it, it explodes. Their face is black. Their entire lab is in shambles. And then the government starts coming towards you, and they're all like, "Hey, I'll give you $1 billion to give me that stuff." Why? Because we want to nuke Russia. Or something like that, as some movies actually say, and lots of people actually stereotypically say all that, and I used to have a Russian friend, so I can't say anything about it, but hey, here we go. So there we go, ahead, and that's not how things work out, and especially not nuking Russia. No one has nuked Russia ever before. The only cities I know of that has been first nuked were Japan, and yeah, that's nothing else that we can actually talk about. Anyways, back to solutions now. Solutions, go ahead. And they're basically just stuff putting together. And like, remember my other episode and another episode where I like put a lot of salt and some water and I started churning them together, and suddenly, voila! You got salt water. And like magic, salt disappeared. Well, it's not actually magic if you expected. Is it? Tell me in the comments below. But anyways, what happened to the salt in the water? Well, imagine that there's salt in the water. This happened when you stirred it at room temperature. It can put in enough grams. You put in just enough grams in it so that it gets soluted. Now, there's a solvent and a solution and a solute. Solvent is the item you're dissolving, and the solute is the thing you're dissolving it in. Like, the salt is the solvent and the water is the solute. Some gases are dissolvable in water, so solvents does not have to necessarily be solids like salt. It can also be gas like chlorine if you just got the right liquid. And I would, first of all, if you even dissolve chlorine, I'd ask you, where did you get all that chlorine? Unless you're a chemist, because, well, one sniff of chlorine will mean with this, of course. And reaction rates and equilibrium. This is where all the equations are, and I didn't even bother memorizing these equations, so I'll probably put them down in the comments or description if I get to it, which I might not do in a year. So, yeah, depends on when you're watching this video. And reaction rates and equilibrium. Now, here's the thing about stuff. Now, chemistry, you can speed up. So can physics. Chemistry and physics you can speed up, and this is really useful because if you wanted to do reactions that are related to biology, then, well, you could do it the old way, and biology itself cannot be sped up. You cannot speed up a wheat seed to grow. You can't just like wait a second and then suddenly a wheat seed just planted a few seconds ago just instantly grows into a healthy white yellow stalk. No, that's not how biology works. Biology cannot be speeded up. However, if a biology experiment includes a chemical reaction that, like the primordial soup, for example, you can actually speed that up, which is really useful because then you can leap yourself ahead and probably simulate some things that would have taken eons if you tried the old-style way, waiting for the reaction to happen by chance. But then we discovered this thing about catalysts. Let me just put these things back. Catalysts. And then after we figured out that catalysts exist, we're all like, hey, let's use these catalysts to speed a reaction. And the good thing about catalysts is that they are unusable up, meaning you can't use them up. You can use them over and over again, but they'll always still be there. The same amount there. It's just something that speeds a reaction up. If you tried it the old biological way about reactions, then you basically have to wait for two particles. If you want, for like let's just say your chemical reaction just two particles colliding into each other, and then if you try to do the old biological way, you just have to wait by chance for two particles to align in the same place. Just go ahead and squash into each other at the same speed, at the same rate. that chemical reaction would happen, but that takes eons or centuries if you're doing another experiment. Decades would still be a bit long, and sometimes that's even longer than a lifetime. And so catalysts are the ones that you put in, and they're the ones who align it and smash the particles together. It's like a coach, like getting his teammates and getting his players. They're all like, okay, well, if the players figured out the rules themselves and tried to coach themselves, they take probably like years to go ahead and be a good team. But the coach is the catalyst, and the coach is the one who trains them all to do the same thing at the same rate, at the same speed. And the catalyst is just the coach for the particles to collide each other in the same orientation, in the same speed, at the same rate. So like it's basically a basketball team, and the catalyst is the coach. Bless you. And then we have acids and alkalines. And acids aren't just the stuff that melt your face and statues, although they are responsible for that. And they're also the things that makes your lemons taste acidic. Da-dang-dong. And that goes ahead to show that acid bases can be used in chemical reactions too. In fact, those are probably the things that are used stereotypically in movies to go ahead and like, what if I pour this and pour this and boom? The U.S. government arrives at your door like during World War II, and they're like, okay, you know what? Yeah, yes, sir. I'll give you $1 billion if you hand over your research. Oh, why, sir? Because we want to nuke Germany, the Nazis. And they're like, no, then you can nuke everyone else in the world. Alright, we'll take it willingly. Okay, fine, I'll take the $1 billion. Too late. Destroy research. Yeah, I actually like to imagine the perfect movie being like that. The perfect World War II science fiction movie. But I'm getting ahead of myself. And that is not even science, it's historical science. And that's not even science, it's not even possible. So I hope you guys enjoyed this episode, and tell me about some things about like perfect World War IIs plus sci-fi movies in the comments below, because I really, really, really want to think about that. Don't give me actual examples. Think of your idea of a perfect movie. And that's it. Hope you guys enjoyed this episode, and see you guys soon. Shine out. Peace. Stereotypical. Actual. Wait. Bye.